Hello everyone and welcome to the next segment of this interview. Here we will be talking about physics in the real world and its real life application.
So for our first question, recently there's been a lot of focus on diffusion energy and its breakthroughs. What do you feel about its implications for the world, and how important do you think it is in the history of physics?
So if we talk about nuclear fusion, yeah, that's true that recently there have been a lot of focus. And the main reason for this is the climatic change, right? The challenge. Now we have the challenge for saving our environment because the climate is changing tremendously and there is a lot of destructions happening all around. So if we talk about the breakthrough, recently, in December 2022, the researchers announced something about nuclear fusion. Do you know that?
Not too aware.
What was the announcement?
In December 2022, scientists they announced that they actually could generate more energy from the nuclear fusion than it was put in, more than what was put in. So that is a tremendous achievement actually. It will really save our environment because nuclear fusion, the advantages of nuclear fusion are it gives us a clean energy, a carbon-free energy, and there are no nuclear wastes. Of course, breakthroughs are very important in the history of physics. If you know about some breakthroughs like the discovery of atomic nucleus by Rutherford and his partners, that was that changed the people's view of looking at the materialistic things around in terms of physics. So the second breakthrough was the Nikola Tesla's breakthrough and Michael Faraday's work on electricity and electromagnetic induction, where they really found out the relation between electricity and magnetism, and now we are using AC generators and motors and many other devices which are related to this. Similarly, Einstein's theory of relativity and Einstein's theory of everything, that is also breakthrough, and this has also added to the history of the physics, and actually it is the nature of science which you learn in your IB also, that we keep exploring, we keep changing our laws based on new and new discoveries.
That's a really commendable breakthrough. We had not really heard that much about it. It's relatively recent, so that means that there's a lot of scope for further research and development as well.
Yeah, because they used lasers to produce that condition for the nuclear fusion to happen. So and they are still working on it because we need money. More investors are investing on the nuclear fusion, and it stores a very good future for our world, where actually we can replace the fossil fuels and other non-renewable resources.
I'm sure that information is incredibly helpful to the viewers. Moving on to the second question. Many topics in theoretical physics like black holes and quantum entanglement seem to have very little application in everyday life, or we so think so. Yet, they're researched upon really greatly. Why do you think this is the case, and do you feel that the attention should be diverted to more tangible aspects like aerodynamics and machinery and aerophysics?
Okay, so I think this notion seems to be wrong, that we do not have much applications of quantum physics and black hole in real life. So, there are many applications around us. If you look at the application in medicine, like radiations, they are actually from the quantum mechanics. So radiations we use for treating deadly diseases like cancer. We have laser light amplification by stimulated emission of radiation. So that is used for many surgeries in medicine. And this is the concept of quantum mechanics is used in communication, like in optical fibers. The classic example is GPS. GPS,
Yeah.
So GPS can be used for tracking things, and it can also be used for giving you directions. And there are many more applications, and many people are using them. And another achievement is Wi-Fi. Wi-Fi is also chance discovery, and I would like to model it like in a way. It's our universe is like made up of 3 layers. So if you look at the outer layer, so this outer layer is just the materialistic world which you look around and use your senses to observe it and form the rules and laws. The second layer of universe, which is again the layer of reality, you need to deep down into the imagination. So you need to use some X-ray vision to look at it, because I cannot see the particles around me. When I drink a glass of water, it's not only about H2O, there are millions of particles in it. So we really need that vision to look at it, and scientists, they really worked on it. So that's their curiosity, the inquisitiveness and the scientific nature which is helping them. And when you look at the particles, these particles, they are all around in the universe, but there is some force which is holding these particles together. So that there comes the third layer, which is the field generated by all these particles and which is holding all these particles together. So it's about exploring the universe.
I think that was really informative and a really unique point of view to know about. So moving on to our next question. So we've heard of physics being really popular among students, whether be in school or university. But a lot of students take physics as a subject even though they do not enjoy it. So do you know why? And as a teacher, do you think it's advisable to go down such a path?
Yeah, that's true. That physics is a very popular subject, and it has in terms of career also, to talk about different careers like in engineering field and in astrophysics. In physics field, there are scientists. Some people, they want to become scientists, and it's considered as a trademark actually. So there is a pressure from the society, pressure from the parents. So students, they end up taking physics. According to me, it is not right. If you just remove all these society pressures from you, just try to understand which subject you are more interested in and work for that subject, master that subject. And yes, if you decide to take physics as one of the subjects, you really need to work hard for it. So, and that is not impossible. Actually, in the modern world, it's very easy. You can watch the videos, you can explore more about physics, you can have peer discussions, you can use technology for understanding physics. So yes, when you decide to pursue it, you have to develop your interest in that. So you cannot end up just taking it, just memorizing the concepts of physics.
I think personally I agree with that too. If I do not have any interest in physics, I do not think I'd be enjoying the subject as much and would be able to score as well.
Yeah, definitely. I feel like if you don't have any interest in any subject, it's not just limited to physics.
Correct. Yeah.
Being in IB, I think it's very important to have your interests and passions sorted out.
Yeah, correct.
And I feel like even like having you as my teacher is really helping me to also understand the concept much better, which also develops that interest in me. For example, if I don't get something, I can always approach you. So it's also very important to have a good leading role model to teach you the subject, to really help you understand it. The last question of the segment is more open-ended. So do you think that we will ever be able to explain every phenomenon or every mystery about our past using physics, or are there some questions in the universe that can never really be understood?
I think the way the researcher, I just shared with you, right? The way the researchers are working on quantum physics and they are studying the universe. We have the Hubble's telescope and several satellites which are, trying to study the universe. So one day we can solve the mystery if we continue with this, curiosity and the scientific nature, and we continue with all the researches.
That was really insightful, definitely. I agree.
Yeah.
So I think that brings us to an end, this segment to an end. See you in the next segment.